Trigonometric ratios of some specific angles. Okay, there are some angles whose trigonometric ratio, if known, can be very helpful. There are simple values to these which can be easily remembered also. Actually, we will be studying these 5 angles: 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So let us first obtain the values for 45 degrees, the trigonometric ratios. With respect to 45 degree angle. Okay, so we all know that we will be starting with respect to a right angle triangle ABC, right angle at B, and one angle is 45 degree. That is, let us say that angle A is 45 degree. And so as we all know that if this is any triangle, the sum of interior angles of a triangle is 180 degree. It can never change. Okay, so in this triangle, one angle is 90 degree, one is 45 degree, so the remaining is also 45 degree. Now, since the two angles are equal, we can say that this is an isosceles triangle, so this comes out to be isosceles right angle triangle. Also, we know that the sides opposite to equal angles in a triangle are equal. So, angle A opposite BC, angle C opposite AB. Angle A is equal to angle C, so AB is equal to BC. Means length of AB is equal to BC. So, if we are going to find out sine A, that is sine 45 degrees, we can say it is BC upon AC, right? We can also say that whose value will be equal to AB upon AC, because BC and AB are same, so it can be replaced. Okay, so now the Pythagoras theorem. H square is equal to P square plus B square, hypotenuse, perpendicular and base. Okay, so this comes out to be AC square is equal to AB square plus BC square. We can replace BC by AB. So it comes out to be AC square is equal to 2AB square. Solving this, we can get that AC is equal to root 2 AB, which can also be said to be equal to root 2 BC. Equal to BC, so we can directly replace it. So let's find out sine A. Sine A is basically BC upon AC. So sine 45 degree, BC upon AC. AC we can put as root 2 BC in terms of BC. So it comes out to be 1 by root 2. Cancelling this BC and BC, we are left with 1 by root 2. So the value of sine 45 degree is 1 by root 2. Next is cos A. Cos A is basically cos A base upon the hypotenuse. So base is AB and the hypotenuse is AC. So AB upon AC, AB upon AC. AC we can put it to be root 2AB, which comes out to be AB upon root 2AB. Cancelling AB, we are left with cos 45 is equal to 1 by root 2. Then tan A. Tan A is basically perpendicular upon the base, perpendicular BC, base BA or AB. So BC upon AB, and AB is equal to BC, so BC upon BC is equal to 1. So the value of tan 45 degree is 1. Now cot A. Cot A we can simply find out by reciprocating the value of tan A. The cot A is equal to 1 by tan A. So cot 45 degree is equal to 1 by tan 45 degree, which is 1 by 1. So value of cot 45 degree comes out to be 1. Now secant A is the reciprocal of cos A. So we can just say secant 45 degree is the reciprocal of cos 45 degree. That is the reciprocal of 1 by root 2. So secant 45 degree comes out to be root 2. Similarly, cosecant A is the reciprocal of sin A, which we can say that cosecant 45 degree is the reciprocal of sin 45 degree. That is the reciprocal of 1 by root 2. So cosecant 45 degree comes out to be root 2. Now let us say for 30 degrees and 60 degrees the trigonometric ratios. Okay. So this is an equilateral triangle here ABC, where all the three sides are equal. That is AB is equal to BC is equal to AC. Okay. And all the interior angles, that is angle ABC, angle BCA and angle BAC, all are 60 degrees. Okay, so AD is an altitude that is drawn from A on BC, so it intersects at 90 degrees. So angle ADB and angle ADC both are 90 degrees. Okay, now we need to find the trigonometric ratios for angle 30 degree and 60 degree. Okay, I leave up to you. You need to figure out that this angle will be coming out to be 30 degrees. 60 degrees we know, 90 degrees we also know. This will come out to be 30 degrees. Okay, how? Think. And so this is a right angle triangle that we get. If we take trigonometric ratios with respect to angle B, then we will get the trigonometric ratios with respect to angle 60 degree. If we take with respect to angle this, DAB, this one, then we will get trigonometric ratios with respect to 30 degrees. Okay, so for trigonometric ratios, we basically need a relationship between AB, BD and AD. When we will be solving, we will get, let's say this is A, this will come out to be half of A, and this we can find it by Pythagoras theorem, and it will, what will it be? Root 3 by 2 A. Okay, so we can get the values of trigonometric ratios as we will have the relation between these three sides. Now solving everything, finally we will be getting a right angle triangle ADB, right angled at D, in which AB is A, BD is half of A, and AD is root 3 by 2 A. Also angle B is 60, angle A is 30. So first we will be doing with respect to angle B the trigonometric ratios, that is trigonometric ratios of angle 60 degrees. Sin B is basically perpendicular upon the hypotenuse, that comes out to be AD upon AB. Putting the values AD root 3 by 2A, AB A, we get the value of sin 60 degree to be root 3 by 2. Now cos B, base upon the hypotenuse, base is BD, hypotenuse is AB. So putting the values 1 by 2A upon A, we get the value of 1 by 2. That is cos 60 degree is 1 by 2, that is 0.5. Tan B is basically perpendicular upon the base. Perpendicular is AD and the base is BD. So root 3 by 2A upon 1 by 2A is equal to root 3. So the value of tan 60 degree is root 3. Cot B, reciprocal of tan B. So 1 divided by root 3, that is 1 by root 3. Cos 60 degree is equal to 1 by root 3. Secant B is reciprocal of cos B. Cos B is 1 by 2. So the reciprocal of 1 by 2 is 2. So secant 60 degree is equal to 2. Cosecant B is the reciprocal of sin B. The reciprocal of root 3 by 2, that is 2 by root 3. So cosecant 60 degree is 2 by root 3. Now for 30 degrees, we will take the same triangle ADB, right angled at D. Now we will find the trigonometric ratios with respect to angle A. So what it makes? It makes BD as the perpendicular, AD as the base, and AB will be AB the hypotenuse. Okay. So sin A is equal to perpendicular upon the hypotenuse, that is BD upon AB, which is 1 by 2A divided by A, that gives us 1 by 2. So sin 30 degree is equal to 1 by 2, that is 0.5. Now cos A is base upon the hypotenuse, base AD root 3 by 2A, hypotenuse AB A, which gives cos 30 degrees as root 3 by 2. Now tan A is basically perpendicular upon the base, perpendicular BD 1 by 2A divided by AD, that is root 3 by 2A, which gives tan 30 degrees as 1 by root 3. Now cot A is the reciprocal of tan A, which gives us cot 30 degrees as root 3. Now secant A is the reciprocal of cosine A, which is the reciprocal of root 3 by 2, which leaves us with secant 30 degrees is equal to 2 by root 3. Now cosecant A is the reciprocal of sine A, that is the reciprocal of 1 by 2, which gives us cosecant 30 degrees equal to 2. So now find the values with respect to 0 and 90 yourself. This will be a very interesting exercise. Okay, so now this is the overall table that we have. Okay, so in this table, on the left hand side I have written the trigonometric ratios, and on the above side I have written the angle with respect to these trigonometric ratios. So we can read this table as putting the value of these angles in place of theta. We can get like sine 0 degree is 0, sine 30 degree is 1 by 2, sine 45 degrees 1 by root 2. We can read this table as such, like tan 60 degree, tan this 60 degree this intersection, that is root 3. So it is very easy to remember this table, as you can see that these are the 5 angles which follow a very nice pattern. So if we know the values of sine theta, for cosine theta, keeping the angles same, we can just inverse the values. For example, sine 0 is equal to cos 90, cos 0 is equal to sine 90. So you can see there is a pattern forming here. Similarly for 30 and 60, sine and cos values are reverse, and sine 45 and cos 45 are the same. Similarly for the tan theta, 90 degree and 0 degree values are opposite, 60 and 30 degree values are opposite, and tan 45 is the same. This hyphen sign means that the value is not defined. Somewhere you will see infinite, somewhere not defined. It is just not defined. And same is the value of secant theta and cosecant theta. These values are opposite for 0. Then for 60 and 30 and 45 degrees, they are the same. Okay. One more thing, you can say that, for example, cosecant is the reciprocal of sine. So sine 0 is 0 and cosecant is 1 by 0. That is not defined. Dividing by 0 is not defined. Similarly here, sine 0 is in the denominator, and here cos 90 degrees in the denominator. Here also cos 90 degree, that is the value of 0, is in the denominator. So these 4 values are not defined. Okay. This table is very useful. We can find different sides if one side is known and angles are known. Let's do some questions and then we will understand it better. Okay. So first question is, in triangle ABC, right angled at B, AB is 15 centimeters and ACB is 60 degrees. Determine the length of sides of BC and AC. So this is the right angle triangle, right angled at B. This side is given as 15 centimeters. This angle 60 degree. This angle is 90 degree. So we need to find this side and this side. So here we can make the use of the table above. This table is very helpful here. Okay. So let's see how. Suppose we say, let's find the value of tan C. What is tan C? Perpendicular upon the base. That is AB upon BC. AB we know 15 and tan C is 60 degree. So tan 60 degree is root 3. AB 15 centimeters. BC we need to find out. So rearranging this, we can get the value of BC to be 15 by root 3. We generally do not keep root in the denominator, so we can just simply multiply and divide by root 3 in the numerator and denominator. Solving this, we get the value of BC to be 5 root 3. Similarly, if now we need to find the value of AC, and we have AB. Now we need perpendicular with respect to angle C and hypotenuse. There are sine and cosecant, right? So let's take sine. Sine C, that is sine 60 degree, is equal to perpendicular upon the hypotenuse, perpendicular AB, hypotenuse AC. AB is 15, sine 60 is root 3 by 2, AB 15 we know. So AC we can find out by reshuffling and solving, which comes out to be 10 root 3 centimeters. Okay. There is one more alternative to do this. Suppose we get any one value, either BC or AC, with the help of this trigonometric ratios, we can find the third side with the help of Pythagoras theorem. Now we have find out BC. Okay, so let us put the AB is 15 centimeter, BC is 5 root 3 centimeters. By Pythagoras theorem, we can find the value of AC, that is the hypotenuse. Solving this also, we get the same value for AC, that is 10 root 3 centimeters, which we were getting with respect to trigonometric ratio also. Okay. Now, next question. In triangle PQR, right angled at Q, PQ is 3 centimeters, PR is 6 centimeters. Determine angle QPR, this angle, and PRQ, that is this angle. Okay. Now we have given these two sides, that is PQ and PR. Okay. So first let us take sin R. Sin R, because if we take sin R, we can say that PQ is a perpendicular and PR is the hypotenuse. So PQ upon PR is equal to sin R. Now PQ is 3, PR is 6. So sin R, PQ upon PR, that is 3 by 6. We are left with 1 by 2. Okay. So sin R comes out to be 1 by 2. Now which angle, that is at which angle the value of sine is 1 by 2, that is 30 degrees. So can I write 1 by 2 as sine 30 degrees? So sin R is equal to sine 30 degrees. Comparing, we can say R is equal to 30 degrees. What is R? Angle PRQ. So we have one angle. Now there are two ways to do this. The other is we can take cos P. What is cos P? Base upon the hypotenuse. Now we have base as 3, hypotenuse as 6. So we can get the value of P from there, like we have obtained the value of R. And there is one more method. As we know that sum of interior angles of a triangle is 180 degrees. So we know the two angles, that is Q and R, 90 degree and 30 degree. We can easily find angle P from there. Okay. So this is the first method in which we have used the trigonometric ratio of cosine. Cosine P is PQ upon PR, that gives us 1 by 2. So cos P is 1 by 2. 1 by 2 is for cos 60 degree. Cos 60 degree is 1 by 2. So cos P is equal to cos 60. So the value of P comes out to be 60 degrees. And the other method is sum of angles is 180 degree. So solving this, we also get this as 60 degrees. So no matter you use this method or this one, we will get the same values of angle P. Now let us do one more question. If sin A minus B is 1 by 2 and cos A plus B is 1 by 2, where A plus B, the values are between 0 and 90 degrees, A is greater than B, find A and B. Okay. So let us do it. Sine A minus B is 1 by 2. For which angle the value of sine is 1 by 2? 30 degrees. So we will replace 1 by 2 with sine 30 degrees. Now sine A minus B is equal to sine 30 degree. So we can directly compare and write A minus B is equal to 30. So now cos A plus B is 1 by 2. For which angle the value of cos is 1 by 2? That is cos 60 degrees. So we can say A plus B is equal to 60 degree by comparing this equation. So we can solve these two equations. We have two equations, two variable. We can directly add them and we get the value of A to be 45 degrees and the value of B is 15 degrees. We can say that both A 45 degree and B 15 degree satisfy these also. A plus B 60 degrees, which is greater than 0 and less than 90. Also A is 45, B is 15. So this is also satisfied. Okay. Now next question. Evaluate cos 45 degree divided by secant 30 degree and cosecant 30 degree. We can directly put here the values that we have learned from the table. Cos 45 degree is 1 by root 2. Secant 30 is 2 by root 3. Cosecant 30 is 2. So putting these values directly and solving, we get the value of this expression to be root 3 into root 3 minus 1 divided by 4 root 2. Now here, we can leave the answer up to here also, but here what I have done is, this is 1 plus root 3. I have rationalized it by multiplying and divided by root 3 minus 1 and using the identity a square minus b square is equal to a plus b into a minus b. Solving this is the final value that has come out to be. Now if we want to replace this root also, we can directly multiply and divide it by root 2. Okay, so this comes out to be root 6 into root 3 minus 1 divided by 8. This is the final value of the expression. Okay, now there are few more questions that are given here. Basically there are 5 more questions that are given here. This one you can practice it by yourself and you can also see how much of the table you have remembered. It will help you remember also basically. The last question is, at what value of theta sine 2 theta is equal to 2 sine theta? This is the last question and just you can try it by yourself. If you can do it, it will be very nice. Okay, this ends the part 3. Part 4 will be uploaded soon. Thank you so much.